All right, we're inside looking at the lab questions, which I've cut and pasted from the lab online. And number one is the one we just did, determining the focal length of a 20 centimeter focal length lens by pointing at the sun, okay? And then you'll write the number that you get, that you measure with the ruler, say, in the text answer to the question, okay? So now we're moving on, and you can come around here and I'll show you what we're doing. All right, what we're gonna do is take the same board, right, with the paper on it, and the same lens, the 20 centimeter or 7.8 inch focal length lens. It's that convex lens. And what we're now going to do is something that the measurements are a little trickier for. Okay? So, to make it easy, you may want to put something behind the board so it can stand up. All right, it did it. Okay. At first, carry your ruler. And now, you're going to try to get an image of the window, right? With the slats there that are in it, okay? Into focus. Oh, see how out of focus it is? And then when you reach a certain distance away, it gets very focused, okay? The window. And let's see, we want to make sure it's the window and not the tree behind it that's focused. All right. So now when I'm in that position, let's measure the distance from the center of the lens out. Okay. It's a little tricky to keep it in position. Let's see. That's funny, that's not exactly what I wanted. Okay, looks like it's about 8.2 inches. Okay, so that will be your S1 or your S2 or your image distance, and your object distance. Now we have to measure. Oops, good thing I didn't break the lens. Okay, because we need it. Oh, they're very resilient. So now, you can use any device you want to measure, say in inches, okay? The distance from that 8 inches out, okay, from the board. So here's 8 inches out, and I'm just going to put this here, right underneath it, and I'm going to measure the distance. Tricky. And try to measure the distance to the window, okay? That could be very tricky. All right. It is about 89 inches. Okay? So now, what we're going to do, if you want to come around here, is utilize the formula in the lab. So the object distance is S and the image distance is S prime. So I guess we got about 8 or 9 for the image distance, and what was it, about 89, 88 for the object distance. So you take 1 over 88, say, plus 1 over 9, okay? And then you divide that into 1, and again you should come up with a focal length that will be fairly close to the 7.8 inches, okay? You keep it all in inches. Then you'll write those numbers, the object and image distance, and the focal length you calculate from the formula, write it into the text for question 3. Well, question 2, I should say, yeah. Okay. So now let's go to question 3. And what we're going to do is a little tricky. Is if I forgot to put the tape, but you can pick the concave lens that has a longer focal length, and this one has a focal length of 50 centimeters, right? But it's negative 50. So when you have a lens that's bending inward on both sides, that's a double concave lens. That's what this is. And its focal length is minus 50 because the only way you can see an image with it is to look through it, and you'll see it on the other side. All right, so now if we take both of those together, right, we will get a combined focal length we can calculate from the same formula we did for the single lens. So now let's look at the same object. Oh, notice I have to go much farther away, okay? So I'm about here. Tricky. About here, and let's get it into focus again, okay? Yeah, not what's behind the window, but the window itself. And now I'm at about, looks like about 12.5 inches, okay, away. So now I'll take the tape measure, go 12.5 inches from the board, okay? And, well, we already know the distance to there was 88. 12.5 from that is 76, okay? So we can put those from here to the formula chart into the same formula, right? For the object and image distance, okay? And when we do that, we'll end up with the focal length for the combo, I call it, okay? The combo is the combination of the two lenses, okay? Taped together makes it easier than the way I did it, but it's simple, okay? So by using the object distance to the lens and the image distance to the lens and the formula, okay, which we used with question 2, we can calculate the focal length of the combination. But then the tricky thing becomes calculating what it should be from the focal lengths that we know from the company that produced them, okay? The 20 and minus 50 centimeters. So you come over here and we'll show them the formula for that. So the focal length for the combo is going to be 1 over the combination of 1 over the focal length for the convex lens and 1 over the focal length for the concave, which will be minus 50, okay? So it's 1 over 7.8 and 1 over 50 divided by 2.54, okay? Converting it, yeah, there it is, 19.7 inches. Negative minus 19.7 inches is the focal length for the concave length. So you put in minus 19.7 there and 7.8 there, and this is what your number should be close to. So you write those numbers into the text for question 3, and you go on to question 4, and you want to get the percent difference between the calculated value from the actual focal lengths produced by the company and the value that you estimate by the object image distances. And then you want to take the percent differences between the two. That's the larger focal length for the combo minus the smaller one, whichever is with that. Take the difference, divide it by the focal length given that we calculated from the equipment, and multiply it by 100, and you'll have the percent difference. Should be within 10%, say. Okay? So write that percent difference into the text for question 4, and you're all done. But one more thing, in case it's cloudy, okay, let's walk outdoors here, and you can't see the sun, okay? You could use the neighbor's house, particularly if the mirror, particularly if the windows are perpendicular to the line to you, right? Because they'll be reflective, and you can get a nice image of the windows, and they're so far away, even if it's 100 feet, right, that they will produce an image at the focal length away from the center of the convex lens you're using. So for question 1, either way is an outdoor thing, either the sun or the neighbor's house, okay? Oh, I didn't mean your son's house. Okay, so hopefully you can manage all this in a great way and put it online, and it's due by next Friday, okay? And also I've changed the question, simplifying things a little bit on the lab so you can do it now, okay? You don't have to wait till Sunday when I said I'm going to have it done. So best wishes on the lens lab, okay?